Welcome back to the channel. So we've got Big Brute back in the shop because it's time to pick up where we left off. What we've got going on here so far is the new Millennium booms are hung by the crane and resting on the scissor lift. We've got them about the height that we want them to be, because remember before, if you remember in the previous episode of this, we had them way up in the air with the original cradle system. Well, we dropped them down because we wanted to be able to clear doors as we go in. So right now, Leg Arms is working on the old cradle. That's what cradles or supports the booms when you're in transit mode, because there's a lot of moment here bouncing like this. So you got to have something to kind of hold it steady. It is anchored here, but you don't want to ride on that when you're cruising down the road. So he's doing the process of figuring out how we're going to mount these booms to attach, because they're completely different than the originals. So when that's all done, then we'll bring it out of the shop and we'll build the back of this out. There's a bunch of brackets that go on the back of here to attach the Weet It systems to. Some extrusion that's got to go on. Then we can start doing all the plumbing, all the wiring harnesses, and then we've got a brain box to put on, and then a Ramsey valve. I'll show you what that is in a little bit here. So we still got our work ahead of us, but it's nice to finally get back to this Brute project and get this thing back in the field with this new Weet It system, this new Millennium booms, and ready for the first chem follow operation. And I'll show you guys just how much money this thing's going to save. It's going to be awesome. So let's get to it. By the way, I forgot to mention, mixed up a can of paint. So I can do all the touch-ups to this thing because, well, remember some of the stuff I had to do to it. It's kind of ugly, so we need to clean that up. There we go. So we had to extend the top of this mount here so the cradle can go up higher, because like the plan is to attach the top of the boom here for cradling instead of the bottom. The reason is we're trying to avoid the Weet It sensors, which are going to be in the front here, because they stick out and we'd want to avoid crushing those at all costs when it wings in. So got to bring it up about 10 inches. So just wrap that up. Leg Arms is finishing up the brackets, and then we'll start installing those, and then hopefully get this thing able to cradle itself. All right, this is what we got so far. So this is the hanging bracket Leg Arms built, and we raised the posts up a little bit. Looks like way too much, but at least that gives us some adjustment to raise and lower this cradle as needed. We've got to reverse these. They're backwards because we flipped it around, so we got to take this, cut it off, flip it, put it back on, so that way it is the correct angle from the way this is on here, but that's not a big deal right now. At least it's on there. So we'll drive it out of the building, wing it out, and then we can start the next process. And then we can take this off and correct that. But we wanted to just make sure this works. So let's drive it out, see if it looks good. These are brackets that are going on the back. Because the way the sensors are, there's not much room to put the Weet It sensors in front of here. They won't work properly. So what's going to happen is you got to put them further in the back, so that way they can see the weeds as they come underneath and then hit them. So you'll see here, we're going to bolt these on. This gentleman's going to bolt it on. I'm going to help him bolt it on. Do you need help bolting it on?
We're going to have to ream those holes out probably.
Oh. Yeah, that's...
No? No?
You getting it?
I have to... Barely fits.
Okay. All right, so we need more washers. So we've been doing some measuring, and this bracket that's going to hold the wet bar and the sensors needs to come down a little further. So we're going to have to slice off the bottom of it to drop it down. But the problem is this hydraulic line here is probably going to hit it, because this whole arm assembly here shifts back and forth the booms. So we've got the Can-Am Defender with its winch attached to the end of the boom so it doesn't swing in because it tried it earlier. We're gonna take this cylinder off, take it over, drop it down in here, flip it upside down, put it back on, so that way the cylinder, or the hydraulic line, the 90s, are on the bottom and not the top. And that way it won't hit that thing. Easy. Just taking longer than it should. Okay, come in a little bit. Oh, sorry, go out. Keep going, right there. Good. All right, she's pinned. Now I gotta put some of this to put these on. So
You can slide those down pretty easy.
Do you have one in the bottom? But just slide into the other one. And then I'll put it in. All right, so extrusion's on. Drop these brackets down. Got 4 bolts there now. We're gonna tie an arm up and have a bracket attached up here. We got another U-bolt. Put it up there, and that way it's triangled. So, I mean, this is actually, well, we'll have to test it. We'll see. The weighted sensors are on the bar. We got 4 on the back here. So put these brackets together. Now we just got to figure out the spacing of them, and then the wet bar down here is going to attach right here. So that's what we're gonna do right now. All right, another day to keep working on this thing. So I'm thinking I want to build some supports. This is pretty sturdy, honestly, but it's bouncing back here. Easiest thing to do is just cross it with some square tubing. So I think I'm gonna build a bracket that'll attach up here to this bolt that's welded to the side of this frame that was originally, I think, the turning light bracket. And I'll come down and angle into the side of this piece right here. So let's measure up some stuff, cut some square tubing, weld her up. I also think I'm gonna pull those sensors off when I weld on there because, well, I don't really want to ruin those sensors, and welders and electricity and sensors, you just don't know. So let's take them off. Right, so I put the sensors back on. This is what I got so far. So I can unbolt here. We need to remove this whole thing, or if it gets banged up or something, it's removable. Cut the extra threads off, didn't need all that, so got to grind off these edges here. Welding in the wind was not so pleasant with a MIG welder, but I did my best. It'll hold. Some paint. No one will ever know. Paint fixes everything. I'm gonna paint a lot of this. Fresh paint. Sensors, we'll paint it all. Okay, it's harness time. Got lots of these. So how these harnesses work, green is for, actually I'm on the wrong one here. I gotta go to the other side. What am I doing here? I'm already messed up. Let me pull that out. I'm over here. Green goes down the right side of the boom. Black goes down the left side of the boom. Here is where the first nozzle is. This is the very center. That nozzle is not gonna have a solenoid on it. This one is. This is number 1. So we just start clipping these bad boys in. Bad girls, bad its. In here, like so. Work our way down, and then the sensor, if I can hold this plugs into the sensor. This one unit goes to the main brain box, which hasn't been put on yet, which is over there. And then these run in series, and we just clip them all together through the whole thing all the way down. Simple enough? Oh, we're already getting rust. That just happened today from a little bit of rain. Oh, don't look at those welds. Hey, what are you guys doing? What are you doing? What are you doing, misters and misses?
Oil.
I like your guys' clothes. Oh no, is that oil? What do you do with it? What do you do with the oil?
You work with it.
That's actually water. Oh, what's that dog? Is that your dog? Your dog.
We got a puppy.
Oh, what's the dog's name?
Maverick.
Maverick? Cool.
Maverick.
Hi, Mav.
Hi,
Okay.
Mav.
All right, get back to work, guys. Get back to work. Stop slacking.
So what I'm doing is I'm putting the harness on all the sensors for the solenoids on the little nozzles. That way we can spread it all out, get it where we want, and then we'll start hanging all the rest of these sensors here as well. And there's a lot of sensors and wires and stuff. But we're gonna go ahead and just get it all on there. We won't worry about getting it all nice and pretty and tidy. And then once everything works and it's showing, then we'll probably go through and start cleaning it up and making it look better, because it's kind of a mess with all the wires and stuff. And then like right here, this is a joint that the boom's gonna fold, so they have a little adapter to extend that, and that's a lot extra. But anyways, this boom here is pretty much done with this harness. I'm gonna go over on that side of the boom and start putting the rest of that on, and then that way we can make sure everything is here and see if there's any complications. And Nick's doing some kind of bracket thing over there, so he's acting busy, unlike me.
Hey, look, we're back at Big Brute. Still going. Still got the Sweden system put together. On and off. It's been an on and off project for the past couple months.
Too long.
Yeah, we want to get it going. And then our land out there is getting to the point where this thing could be used. So we want to really get going. Leg arms putting, this is the main brain box bracket, and he's putting the box on right now. That's that white unit right there. So that's all the brains behind this project. That'll talk to all the Weedit system and tell it what it needs to do. So I got to figure out the harness, get that lined up to run to the front of the cab, get in there where the monitor is going to be. We've got that harness here somewhere. I think it's actually on. Maybe it's attached. No, that one's not that one. And then we got to get a power back here. So we got stuff to do. Let's get on it. Let's get this brute wrapped up. This is called the Ramsey valve. It's a needed part of this Weedit system. Basically uses air pressure, there's a diaphragm in there, there's an inlet and outlet. One goes in line of your pressure line running to the back of the boom. The other one goes back into your tank, which is going to be that port right there. And what will happen is this helps regulate the amount of, I say volume, not pressure, volume to the back of the sprayer. Because with a Weedit system, running those little green guys up there, you don't need a lot of volume. And sometimes very little, because sometimes you're just a couple nozzles are turned on and off. It's not just a constant broadcast. So this is one of the methods they use, and how it is air pressure. There's the airport right there. This truck's got air pressure on it. Got an air compressor. So I got to mount this baby. I'm going to put it right here on this frame right there. Then we'll run an air line over, tie it in, and I got to put something down so I can show you what I'm doing here. So it'll go here. There'll be a line and a line. This will come off, tie into it, and then we'll come around and run up, go into here, and then the main line then will continue on down to the back. And then you've got an adjustable air regulator that you adjust the pressure to that Ramsey valve. Does that make sense? Let's put it on. Flat iron, angle iron, flat iron, angle iron. Don't need to be that thick. Is there any scraps here I'd like to use? Those are all pretty heavy iron. I don't need that heavy. And angle iron. Oh, where are you hiding? You're here somewhere. That would work. A little thin, but it would work. That's solid right there like that. That should be plenty strong. Changing some plumbing. We're going from 1.25 inch to 1.5 lines from the pump all the way to the back of the valve body. So that way, or valve remote, manifold, valve manifold. So that way we've got good flow all the way back. I mean, with the weeded system, like you guys probably think, why do you need that? Because you don't use a lot. Well, yes, when we're using the weeded, we don't need that volume. But now we have 120 feet, and when we do broadcast spray, like say crop spray or desiccate, or you never know when we're doing 10, 15 gallon work for some reason, possibly liquid fertilizer, we don't think we're gonna do that. I want a little more flow. The pump can do it. We just had it neck down. It doesn't need to be that, so let's open her up. I just took the ends off that, and there's a bunch of junk in there. I don't want that. There we go.
It is a mess of wires on this whole entire boom. And the reason why I'm not going to go through and zip tie everything up and making it pretty is if we have to change something, then you got to cut zip ties and start over. So we're just stringing it all over, making sure we have all the connections, everything looks good, and then once it starts working and we think it's fine, then we'll zip tie it. But one thing I need to do is the exhaust right here. We decided, as much as I love a stack, and I think it'd be awesome to keep a stack, we decided not to put a stack on it. Probably because he thought it was a great idea not to put a stack on it, and I agree with him. If we put a stack on it, it's gonna hit the boom.
Put a stack on it. They're gonna tell you it's dumb. They want a stack.
Yes, you guys are gonna tell us that we need a stack. Here's our logic behind that. If we put a stack on, it's gonna be pointing right at that boom and just heat, exhaust all over the boom. We really don't want that. And if we lower it, it's just gonna still put soot and everything over the boom, and we still don't want that. So either way, because the way these booms are set up, it's gonna be in the way. So we decided we're gonna run the exhaust down below alongside the frame, and we'll put it down here somewhere and shoot it out the side or on the ground. Not ideal. Maybe later we'll put a stack on it, but for right now, this is the most logical thing. So take the elbow, turn it down, get a measurement what I want. We have this elbow here. Oh, that actually would be a pretty sweet stack. Well, we could put it up at the front like a versatile.
What do you think? See? I know they're saying it. You can do it.
Well, we could do that, doing a flapper on the top, go straight out the top.
Just do a 5-inch right out like that.
It's not chrome though.
No, it's not.
No.
This would have been like a $1,500 tube if it was chrome. Okay. You guys can figure it out. I'm not gonna.
It's kind of a tension hog, huh? So am I. So it's kind of a genetic thing, runs in our family. All right. Anyways, I guess I'll start figuring out how I want to run the exhaust down and then make a hanger for it. And we always have the option of putting a stack on it later. But for right now, we just got a lot going on. We really need to get this thing going because there's a lot of chem fallow that needs to be sprayed, and we're eager to see how this thing runs. So anyways, all right. Let's get it figured out.
Okay. We've got goodies. Had to make a trip to the nearest city, 90 miles away. We got all kinds of fittings. A new 1.25-inch ball valve for the main master valve that turns on and off the entire thing. The original one was, I think, an inch valve. You guys saw earlier how it was neck down so tight. I'm converting everything over to 1.5. I mean, honestly, that's overkill. You don't need 1.5. I mean, I think this is 1.25. It's gonna go to 1.5 on out. I might slowly convert the whole thing to 1.5, but like you look at the size of that opening right there, makes sense. See the light on it? See how big that is? That's the original opening. That's all the product went through that. And there is the new opening. Let's get you guys a side-by-side comparison. So we're going from this to this. Does that make sense? Yes, absolutely does. So I'll get this all together, get this all assembled. We got Nick from Weed It coming, so he's gonna help us do some of the wiring and some of the other items. So we got a lot left to do on this thing. It's just been slow on and off project, but we're seeing light at the end of the tunnel. That's awesome, so let's get to it. Got some goodies sent to us to help out some of our projects. So Let's get this in here.
Some of those.
There, now we made some space. Let's get back to business. More? Yes, I can. No, I can't. Stop right there. One more turn. Let's see here. Oh, I have it backwards. I can turn that. That's not a big deal. Oh, and everything comes together like it's supposed to.
It's very possible we'll have to move that tank just slightly up, like the hydraulic tank.
Oh, yeah.
Nick was very generous to drive down to Great Falls and grab some steel so we can build the new cradles, because we're going to do a little different design on what the old booms had. And basically we're going to weld a big heavy 3x5 tubing up here, cradle up, and so forth. So I kind of got an idea what I'm looking at for an angle. Basically what I got to figure out is if it's a 3x5 tubing and you slice an angle on it, it could be a 3x7, could be 3x8, because your length is going to change. So I've got this bad angle thing, and figured out a 45-degree angle actually works out pretty well, because I got to clear the tank. Since the stainless steel tank has a bow around the outside, I got to be able to, instead of going straight up and then over, I got to go at an angle and then make an angle to cradle that. And so there's a little bit of figuring to do. Anyways, 45-degree angle is what I'm going to look at. I'm going to cut one of these at a 45-degree angle, and then I won't worry about the angle up above to hold the boom just yet, because I think I'm going to wing it. So I'll extend it up so far, cut it off, weld that piece on, and then I'll figure out my cross piece over, and then we'll cut that off, weld that on, and just kind of wing it. Nick's using the plasma cutter right now. When he's finished, then I will start chopping away at these tubes here. But I do have to figure out how much of a length I need to keep on them. And the size of steel that we decided to go with is 3/16 thick. And I think it should be plenty strong enough. I mean, plenty. It's probably overkill, but that's okay. We don't mind overkill, because overkill is kind of a nice thing at times, because then you don't have to worry about problems later on. I'm going to do 4 feet, should be plenty. And then once that 4 feet piece is cut at an angle, we'll weld it on and go from there. But I can't cut it until Nick's done with the plasma cutter. When he's finished, then I'll start chopping away at it. Done. not only are we running a Weed It system on here, but Raven, we're actually working with Raven, and they're actually putting a 7-sensor auto boom on this as well. So what I mean by that is we actually have sensors, and there's one right here. There's 2 on each boom and 1 in the center, and as you're driving through the field, it auto height and float and whatnot, and makes your booms not hit the ground as much. So that's pretty cool. But that being said, we have to install a hydraulic valve body that ties into the original valve body, which is right here by Raven, and then we got the control module right there. And what I got to do is I got to tie in the hydraulic lines into it. So we got a bunch of fittings. We're going to make some hoses, and I think I'll get that taken care of today. Nick's doing a fantastic job on zip tying everything up. We laid out all the harnesses, made sure everything looks good, and now he's just making it so that they shouldn't rub on stuff. And yeah,
I'm doing something really important too. If you look closely here, see the zip tie? See the success? We don't like that. So what we do is we cut it with something at an angle to get it as sharp as you possibly can get it. See that really point right there? Beautiful. That way when you're working in here and you forget about that, blood everywhere.
like I said, he's doing a great job. And yeah, that's all I can ask for. So anyways, let's get some hydraulic fittings mounted onto that. And then I'll start figuring out the length on hose and crimping and making hose. Yeah, so we're going to use 2 half-inch hoses for pressure and return, and then there's going to be 2 3/8 hoses to run these lift cylinders right here. Now I'm just going to put the fittings on and kind of figure out which way I want to reroute the hoses, get them at the angle I want, and then I'll start measuring out the hose length and cutting some hose and crimping them.
Now that we got the booms fully buttoned up, everything's zip tied, plugged in, plumbed, hose clamps tightened, everything's tightened. We won't know some of that until we get some pressure in the system and then see if water starts spraying out of places. But if it doesn't, then we're good. But that's all done. Ah! Now we got to finish the cradle. There's more things to do on the cradle side of things, which is right here. It's not done yet. So I'm thinking I'm going to disassemble the old mount system that's sort of holding the booms right now. They'll rest on this temporary, well, this isn't temporary, this is permanent, but what Legarm just made, and then we'll finish doing the vertical stops and then probably cross both sides together so that way it's solid. And then I also got to get the primer out and some paint. I got to start taking care of all this raw metal that's back here, as well as the cradle when it's all done. So there's still more to do, but we are just checking things off slowly. Also, I need to make a support. It isn't bad, but there's a little bit of a jiggle there, and over time, so I want to hook this extrusion here to here, strap it somehow, so that way that last wet bar doesn't shake much when it's in here.
Good deal. We got the exhaust moved over, the air cleaner moved, and the plumbing is all done. Or tubing, or venting, or suction, or what do you want to call it? Exhaust intake, let's put it that way. Anyways, as you can tell, we basically reused everything here except for I had to add about 16.5 inches of tubing, which is 6-inch diameter, to the air cleaner box, move the air cleaner box, and then we moved the exhaust, which used to be right here, and it would have hit the boom, moved it closer to the cab, and I think it looks okay. So at least we still have a stack on it. And we were worried about the stack on the top, if it's going to be blowing onto the booms, and it's not going to. It sits above it, looks great, I'm happy, and it really wants to go spray. I know Nick does.